Welcome to my next tutorial. In this tutorial, I will cover all set and frozen set methods. Set and frozen set are two different built-in data types in Python. And like everything else in Python, set and frozen set are also objects. A set is an unordered collection of unique items, and unlike sequences, they provide no indexing or slicing operations. A set can only contain immutable objects like numbers, strings, tuple, or frozen sets. Here I have declared a set myset1 which contains only integer objects, whereas myset2 contains integer and string objects, and myset3 contains 3 tuple objects. Frozen set objects are just like set objects, but they are immutable objects, which basically means that they are read-only sets. To create a frozen set object, you can call built-in method frozenset as shown in this example. Now let's first look at methods supported by set objects. If you call built-in function directory on a set object, it will return all set-specific methods. Methods which start and end with double underscore are called special methods, and they are not set-specific methods. However, I have covered most of these special methods in one of my other tutorials. So let's start with add method. Add method takes an element as argument and adds it to the set. Since set cannot hold duplicates, so if the element already exists in the set, add method has no effect. In this example, I have added a new integer element 12 to my set1. As you can see the output, my set1 has now new element 12. Now if I again try to add integer object 12 to my set1 will remain unchanged. Since a set can only hold immutable objects, you can also add tuple or string objects to your set. The clear method is very simple and it removes all the data from the set. The copy method creates a new set by making a shallow copy of original set, as shown in this example. The difference method takes one or more sets as argument and returns a new set which contains only those elements which are not in the argument sets but in the set which has invoked the difference method. In this example, I have two sets, myset1 and myset2. Now I call difference method with myset2 as argument. The difference method returns a new set which contains all the elements which are in myset1 but not in myset2. Similarly, I can have multiple sets as argument. The difference update method is just like difference method, but it modifies the original set, as shown in these examples. The symmetric difference method takes a set as an argument and returns a symmetric difference between the original and the argument set. In other words, it returns a set which consists of elements which are in either of sets but not in both sets. The symmetric difference update method is just like symmetric difference method, but it also modifies the original set. The intersection method takes one or more sets as arguments and returns a set which consists of elements which are in original set but also in argument sets. In this example, I call intersection method with my set2 as argument, and it returns a set which contains elements which are in my set1 and in my set2. In my next example, I call the intersection method with my set2 and my set3 as arguments, and intersection method returns an empty set. The intersection update method is very similar to intersection method, but it modifies the original set. The discard method takes an element as an argument and removes that element from the set. If set contains no such element, no exception will be raised. In this example, I call discard method to remove integer element 5 from my set. In next example, I again call discard method to remove element 5 from my set 1. But as I have mentioned before, discard method throws no exception, even if there is no such element in my set. Whereas remove method is just like discard method, but it raises key error exception if the element is not found in the set. The pop method is just like remove method, but it removes and returns an arbitrary element from the set. If set is empty, pop method raises key error exception. The union method takes one or more sets as argument and returns a new set which contains all the elements from the original set and the argument sets. In this example, my set 1 contains 2 elements and my set 2 contains 3 elements. Now when I call union method with my set 2 as argument, union method returns a new set which contains all the elements from my set 1 and my set 2. Similarly, you can have multiple sets as argument. The update method takes one or more sets as argument and updates the original set by adding elements from all other argument sets. In this example, I have 3 different sets and I call update method with my set 2 and my set 3 as arguments. So my update method updates my set 1 so that it contains all the elements which are also in my set 2 and in my set 3 as shown in this example. The isdisjoint method takes a set as an argument and returns Boolean value true if the original set and the argument set have no common elements. Otherwise, it returns Boolean value false. The next two methods issubset and issuperset are very similar to each other. Issubset method checks if the set passed as argument is a subset of original set. If yes, it returns true. Whereas the superset method checks if the argument set is superset of original set. If yes, it returns true, otherwise it returns false. In this example, I have 3 different sets, and I call issubset and issuperset methods to check whether they are subsets or supersets of each other. Now let's move to Frozenset objects. As I've mentioned, a Frozenset object is just like a set object. But Frozensets are immutable objects, which basically means that once they are created, they cannot be changed. So Frozenset objects don't support methods like add, remove, clear and update, which I have covered in previous slides. In this example, I have created a Frozenset object by calling built-in Frozenset function. This is the only way to create Frozenset objects. Now when I call built-in function directory on my Frozenset object, you can see all the methods provided by Frozenset class were also available for set objects. Because a Frozenset is just like set object, except it cannot be changed once created, so all these methods work exactly like methods of set class that we have covered in previous slides. I hope now you have basic understanding of both set and Frozenset methods. Thank you for watching and please subscribe my channel for future tutorials.